Advanced Studio Classroom is on the air. Join us today as we continue talking about NASA's plan to save us from space. Hello, listeners. Welcome back to another Advanced Studio Classroom. I'm your host for today. My name is Simon, and you are joining me in the studio as we discuss a space article for the month of August called Challenges in Space. Now, the lesson we're going to do today is the lesson for August 2nd, and this is actually the second part of this article's lessons. But it's a continuation of the article we started yesterday. And in that article, we were talking about a big risk that the Earth faces from space. Now, how big this risk is really depends on your point of view. But the one thing that was very clear by the end of yesterday was that we were not talking about aliens. We're talking about a totally different risk. Manya, tell us, what is the risk?
The risk is we're afraid that maybe a big rock will hit us.
Okay, and we used a special term, right? What was the term we used for those rocks?
Asteroids?
Yeah, that's right.
We talked about many terms yesterday. I wasn't sure which one you were talking about.
Now, Manya, I didn't take the chance to welcome you back to the program again today, but I want to do that. Manya, welcome back.
Thank you, Simon. I feel so welcomed.
It's good to have you here discussing asteroids with us. Our other panelist today, listeners, is Jack, who's returning again for the second day of the program.
That's right. And so, we talked about asteroids, and we talked a little bit about meteors also. So when an asteroid enters Earth's atmosphere, it can become a meteor.
Okay. And we read yesterday that NASA has a plan. Now, you'll notice today, listeners, that I am saying NASA the right way.
I wanted to clap for you.
At least the American way. This is constantly a matter of difficulty for me, but I've focused on it at least for today. So I'm going to be trying to say the word correctly. NASA has a plan. What is their plan, Manya?
Well, their plan is to run a test using a spacecraft. They want to use the spacecraft to hit the asteroid to divert it off its course so it won't affect the Earth.
So in very simple language, the plan is NASA has developed this spacecraft they're calling DART, and they're going to shoot it at an asteroid to try to make the asteroid change where it's going.
Yes.
The idea being, if an asteroid is ever heading towards Earth, we might be able to give it a little bump and make it miss us. That's the idea, right? Because we learned yesterday, Jack, that asteroids, when they become meteors, and the difference, of course, was that meteors are hitting the Earth or coming into the Earth's atmosphere, whereas asteroids are just kind of orbiting out in space. So when a meteor is coming, they can be very, very dangerous, right?
Yes, we're talking about the kind of force that an atomic bomb gives, like the kind of bombs that were dropped in World War II.
And there was a very recent example of a meteor actually coming into the atmosphere. As far as I know, the full-sized thing didn't actually hit Earth. It exploded up in the atmosphere, so up in the air. But even that explosion was large enough to cause all kinds of damage. We read yesterday that 1,000 people were injured in a nearby city, mostly from broken glass, because the shock wave from the explosion destroyed a whole bunch of windows. But it also affected a factory, right? What happened to the factory?
The roof of the factory collapsed as a result of that.
Okay. And so today we're going to continue on with our lesson about this NASA program. Now, we found out yesterday that meteor that exploded over Russia, that was in 2013, right?
Yes.
But this has been something that I guess scientists, astronomers, government people have been aware of as a potential problem for a lot longer than just that, because today we're going to find out that this idea of defending us against space against asteroids has actually been around and been something that people are working on for quite some time. Let's do our first reading and find out a little bit more about that now. Listeners, if you have your advanced magazine, you'll find this first reading on page 12, and you can follow along with us.
In the 1990s, Congress ordered NASA to locate dangerous asteroids in the solar system. Researchers today aim to catalog the orbits of 90% of asteroids 460 feet or bigger. They predict 25,000 of them hurtle through the solar system. CHODIS said they have found and charted about a third of them. The researchers can calculate each asteroid's trajectory decades into the future. Scientists have long debated what to do if they discover one on a collision course with Earth.
So we find out at the beginning of the reading that at least since the 1990s, people have been interested in this idea in the United States. And we know that it's probably been a subject people have talked about a lot earlier than the 1990s because it was Congress, it was the government that was discussing this in the 1990s. And they actually took some action. They ordered NASA to do something. What did they ask NASA to do?
Yeah, to locate dangerous asteroids in the solar system, and apparently what they considered dangerous were asteroids of 460 feet or bigger, and they wanted to find at least 90% of those.
Okay, so they gave NASA some instructions. Basically, the instruction was, find out what the risk is, if there's a risk, and how risky it is. I guess that was the idea. And so as a result, the space agency started to catalog the orbits of 90% of asteroids that are pretty big. So when we say catalog something, I think of a catalog as like a magazine that is selling things, but that's not what we're talking about here, right?
Yeah, no. I mean, in the same way, it's like a collection, we might say, a collection of clothing items or something like that. Well, in this case, it's a collection of asteroids in the universe. But yeah, it's not the kind of catalog that you would shop from.
Now, these days, listeners, younger listeners won't be familiar with the term card catalog. But if you're an older listener, you might be familiar with the idea that libraries didn't always let you search their books through a computer. You used to have to look through little cards. And that's a good description of what we mean by this term catalog, where it basically means you're collecting information on and organizing the information about something. And so it's kind of like doing a survey or an inventory and then organizing the information. But here, they're actually collecting the information on orbits. So we actually used that term yesterday when we were talking about what asteroids do. We said they orbit around the sun. So when we say orbit around the sun, it just means the path they follow around the sun. And so basically what they're doing here is collecting information about where these asteroids go and where they are going. I guess where they have been and where they are going, right? They say that they predict 25,000 of them are hurtling through the solar system. Hurtle. What is that?
That means they're moving very quickly through the solar system.
Okay. And they've found and charted about a third of them. Now, this is another interesting term. They've charted a third of them. What do they mean by that? Is that different than cataloged?
Well, when it comes to charting, a chart, you can think of something, another word we use is a graph, and usually it means it has like an X and a Y axis, maybe even a Z or something if it's 2D or 3D. And so they're not only recording the size of these asteroids, but they're also recording the path that they're going to travel on.
Yeah, I was thinking, when I read that word chart, the thing I was thinking about was it's kind of another word we use for map. Yeah. Especially when you're sailing, you look at your charts. Yeah. And the idea being here, I think, that they've basically created a map of where these asteroids are and where they are going. And so, but only for about a third of them. So this project is ongoing. And it tells us that using this information, the researchers can calculate or figure out each asteroid's trajectory, which basically means where it's going. decades into the future. So lots of time before the asteroid, causes any trouble. And so the question then becomes, what do you do if you find one of these asteroids is headed towards you? It's headed on a collision course, so it looks like it's going to hit you. What do you do? Well, that's what the DART strategy is all about, and we'll find out a little bit more about that in our second reading.
DART offers a strategy. The team has begun the final design and construction of the DART spacecraft. About the size of a Honda Civic, it's scheduled for launch in summer 2021. While it sounds simple, the crash mission involves some tricky engineering. The target is the tiny moon of an asteroid. The moon is not much bigger than the Washington Monument in D.C., minuscule in the scale of space. The spacecraft will be powered by solar panels that unfurl like wings. Its journey will take more than 1 year, and the researchers will be flying blind mostly.
So you have to kind of imagine the situation here, listeners. Let's say that scientists have discovered there is an asteroid heading for Earth, and they have to decide what to do about it. Well, before this strategy, the DART strategy, was developed, they didn't really have a plan. But now they're testing a plan. And so it tells us here that the team has begun the final design and construction of the DART spacecraft. Now, yesterday in the lesson, we talked about what DART means. What exactly does it mean, Jack?
It's an acronym, which means every letter stands for another word, and so it stands for Double Asteroid Redirection Test.
Yeah, and yesterday we talked about how the test part was because there isn't an asteroid heading towards us right now, so they're just testing the technology. Redirection means you're changing the course of something, so you're making it go in a different way. But the double asteroid part, we left that part. We weren't going to discuss it yet, but we're now coming to that part in today's lesson. It tells us that the spacecraft is about the size of a Honda Civic. What's a Honda Civic?
It's a car. It's not a very big car, actually. It's quite small, quite compact.
It's a very popular car.
And it's very popular, yes.
Very popular in North America, right? It's kind of... Well, tell me, who would drive a Honda Civic?
I would.
I would. Yeah, I was going to say, I would drive. I almost got a Honda Civic at the time when I was getting my first car.
They're an interesting car because they are affordable and reliable, right? Usually. They have a reputation of being so. And so it's often, in North America, families often have more than one car, right? So often they'll have an SUV that's bigger and uses more gas. They use that to carry children to things like soccer and haul around groceries. But when they're making shorter trips or they want to save some fuel, they'll often have a smaller car too, and the Honda Civic is a perfect car for that. So the spacecraft is not very big because it's only the size of this smaller car, and they're actually going to launch it.
Wow.
In 2021.
Yeah, the test is going to happen.
Okay, now this does sound simple. We've been using language that simply describes this process for, this is the second day we're doing it now. Basically, we've been saying we're going to shoot this Honda Civic-sized spacecraft at an asteroid and hit the asteroid and bump the asteroid so that it changes direction, right? But they tell us here that this is actually kind of tricky. They describe it as a crash mission because they're trying to crash the spacecraft into the asteroid. But they say it involves some tricky engineering. Can you tell me a little bit about that, Jack?
Yes. So if you can think about it, so the target is a tiny moon of an asteroid, which means it's smaller than the asteroid that they're trying to hit. It's not much bigger than the Washington Monument in D.C., which is, of course, a very tall rock tower or a stone tower. But when you think about, actually in the size of space, when you're trying to travel a far distance, that's not a very big target at all. And so they're trying to hit a very small target at a very far distance with a small car-sized missile.
This whole thing just became very tricky in my mind.
Yeah.
Because, we've been talking about asteroids as like a rock that's flying around, right? But now we're talking about it like it's a tiny planet because it has its own moon, its own mini asteroid orbiting around it, right?
Yeah.
And that's where we get that double asteroid part because there are actually two asteroids here. One is the moon and one is the asteroid itself that's kind of like a little planet.
And just to clarify, they're trying to hit the little moon around this bigger asteroid.
That's it. So they're trying to hit the moon, and it's very small. It's the size of the Washington Monument. Now, can you think of something our listeners might know that's comparable in size to the Washington Monument? I guess the question is, have either of you been to the Washington Monument?
I have, yeah.
You have?
I have not.
Oh, I need to see neither have I. So I'm glad Jack is here today. How big is this thing, Jack? Would you say it's as big as like a skyscraper? Like a building?
It's smaller than a skyscraper. It's not as tall, and it's much thinner than a skyscraper.
So how many floors would you say it's high? Like a 5-story building?
More. No,
building?
it's probably at least 10 stories. It's pretty tall. I mean, but it's maybe only the size in terms of how big around it is inside, maybe the size of a very large room or something.
Okay.
Yeah.
Now, you can go inside, right?
Yes, you can, yeah.
Okay.
Yeah.
So it's big enough for people to go into. It's not a tiny thing.
No.
But, it's much bigger than a Honda Civic-sized spacecraft.
Right. But when you compare it to the rest of space, I'm sure it sounds...
Well, and it's thousands of kilometers away.
Right.
Yeah.
So it's a long way away. Quite the tricky bit of engineering, I guess. Jack?
And then we get to later where we learn that they're going to be flying blind, mostly.
Yeah, what does that mean exactly?
Well, I mean, when you're flying blind, it's exactly what it sounds like. It means you're trying to fly without looking.
Without being able to see.
Without being able to see, yeah.
Well, this term is actually fairly common when you're talking about airplanes and flying, right? You say flying blind.
Yeah.
What would a situation be where a person would be flying blind? Okay, I got one.
Okay,
don't worry about it, you two. Don't worry. I ask you these tricky questions. That's what the host gets to do. What I was thinking about is like if a pilot is flying an airplane and they're flying in a cloud, they can't really see out the windows, right?
Okay.
So they have to use their instruments. Right? And the sensors and things like that to figure out what is going on around them.
The only example I can think of is Luke Skywalker at the Death Star trying to go down the channel.
I think my
Star
example
Wars.
was better. Let's stick with my example of flying blind. But people do use this expression outside of just flying too. Like they use it when they don't know what is going on around them, right?
Yeah.
Where they're trying to accomplish something, but they can't get a clear picture of what's happening.
Right.
So
I always think about in movies when someone's on a mission to do something, then they might be going in blind, flying blind.
Going in blind,
yeah. They're just proceeding by guesswork.
Okay, so we're not talking about necessarily literally being blind. We're just talking about like not being able to see what's going on, right? They tell us, too, that the solar panels will be powering the spacecraft, and they have to unfurl like wings. And the journey will take more than a year. So that's some interesting information. Now, that brings us to our third reading, where we're going to talk about how this DART, that is a solar-powered spacecraft the size of a Honda Civic, and that is going to crash into a fairly small asteroid, how it's going to work. So let's do that third reading now.
They plan for DART to reach speeds as fast as 15,000 miles per hour. The crash in October 2022 will fling debris from the asteroid moon. The team wants to hit the asteroid moon with enough force to bump it, but not break it apart. The moon orbits the asteroid at a speed of about 7 inches per second. They hope to change the speed by about a centimeter per second. In theory, a series of taps over time could deflect an asteroid off a course for Earth. One impact may suffice if scientists have enough warning time. An imminent asteroid strike, however, would require multiple launches and impacts.
Okay, so the term that comes to mind when I listen to this reading, and Jack, thank you again for doing the reading for this, is the term chain reaction. I think that's a really good way to describe what's going on here. Can you tell us, Manya, what a chain reaction is?
A chain reaction is when you do one thing that sets its course. So you might be affecting the rest of the steps that would naturally follow that.
So when you have a chain, like the noun, it's like a rope, but it's made out of metal links or whatever that are together. And I guess the idea is that one part of this chain is connected to the next part. Mm-hmm. So it's kind of like doing one thing that causes another thing that causes another thing that causes another thing to happen, right? So that's kind of what we're talking about here, because the spacecraft, the DART, is not actually very big. It's not big enough to blow up an asteroid or push an asteroid out of the way, because this is a pretty big asteroid that's flying very, very quickly, right? So the plan is that they're going to get this spacecraft out of Earth's atmosphere. They're going to speed it up to 15,000 miles per hour. They're going to shoot it towards the asteroid, and it's going to hit the asteroid's moon in October of 2022. Now, when it hits the moon, they say it's going to fling debris from the asteroid moon. So when you're flinging debris, we use that term like space debris before, right? Space junk. Or are we talking about the same debris?
Okay, so the debris we were talking about earlier was kind of describing the asteroids themselves, which is that, well, asteroids are maybe like big chunks of rock that have split off other planets, or maybe they were bigger asteroids that broke into pieces. But here we are talking about debris from this smaller asteroid, so it's just going to be even smaller chunks of rock and dust that were knocking off of this small asteroid when we hit it.
So we can expect that this DART spacecraft is going to hit this moon with enough force to kind of shoot pieces of the moon out into space, right? But they don't want to break that moon apart or blow it apart, right? It tells us in the next paragraph that the team wants to hit the asteroid with enough force to bump it, but not break it apart. Now, what are they hoping the moon will do after it's hit here?
Well, they want to basically just slow it down a tiny bit, and so right now this moon is orbiting its larger asteroid at about 7 inches per second. They want to slow it down by about a centimeter per second. So actually just a very small change to its speed.
Okay. So this gets a little confusing here. They're going to hit the moon. The moon is going to move more slowly around the asteroid, and that's going to change where the asteroid is going?
No, I believe that's why they're just calling this a test. I don't believe, because what I'm guessing is they probably don't actually want to change this asteroid's direction, because maybe it's on a path that they feel is, it's on a good path and we'll just let it go through it on its journey and it won't affect anything else. I'm guessing they just want to change this moon because it's a little test that they can do to see if they can change that moon without really changing one of the asteroid's paths.
Now, here's what I was thinking when I read this. I did a little bit of looking into this. But it seems to me that the idea is that it is bad to blow up an asteroid because you don't know where all the pieces are going to go, and you don't know how big the pieces are.
That's
right.
That's why.
So it seems to me that that's why they're focusing so much on this idea of bumping. And I think the thing to remember is, we here on Earth, we have a moon, and the moon is moving around us, but the moon is also pulling on our Earth. And so it moving around the Earth is pulling on the Earth. And I think the best example of that is tides. Like when the water comes in and it's higher at the beach at some times and then lower at other times, that's an example of the moon sort of pulling on the Earth. And so I think the idea is that if you change the way the moon is moving around the asteroid, you actually change the direction the asteroid is moving. And so they actually go on to say here that in theory, a series of taps over time could deflect an asteroid off a course for Earth. So if they repeatedly nudge this moon, then it will make the entire thing kind of wobble more onto a different course. Now, they use this term taps, which means a very small hit again. And I think that's, again, from what I gather, you don't want the whole thing to explode into a bunch of big chunks that are flying everywhere.
Yeah, that's why we can't just like send a nice big bomb up there and blow it up.
Don't overdo it. Don't overdo it. That's what they're saying. So they say one impact might suffice if scientists have enough warning time. Suffice, Manya?
Be enough.
Yeah, okay. So they might only need one dart to save us if scientists have enough warning time. They say an imminent asteroid strike, however, would require multiple launches and impact. So this is, I think, kind of, again, what we were talking about. If you are able to hit this asteroid or the asteroid's moon far enough away, then you have a lot of time for it to change course on its own. But if it's closer to Earth, when you find out, you might have to hit it several times and speed up the process, I guess, with the idea. Well, now we can all sleep securely, knowing that we don't have to worry quite yet, both because there is no asteroid heading for us and because there is a plan for doing something about it if it happens. We'll have to watch closely over the next few years and find out what exactly happens with this project to find out if this idea really does work. Now, listeners, that brings us to the end of the second day of our space article, but we're going to continue on talking about space again tomorrow. So I'd like to encourage you to join us for that program. Until then, I'm Simon.
I'm Manya.
And Jack.
Saying bye.
Goodbye.